Hello again, it's Bob from White Dog Garage, and in this episode I'm going to show you some machining of the attachment lugs for a brake arm on a motorcycle swing arm. Motorcycle brakes are usually centered on the axle, and to prevent them rotating with the wheel when the brakes are applied, there is a bar that runs between a point close to the pivot point of the swing arm back to the brake unit. It doesn't matter whether it's drum brakes or disc brakes like it is here, you still need to stop that brake rotating. The rod itself goes under a number of names. It can be brake rod, as I'm calling it, torque arm, torque rod, and so on. But they all serve the same purpose of stopping the brake rotating with the wheel. This is the swing arm and brake caliper unit, rear brake caliper unit out of my Katana. The brake arm goes here, got a bolt with the shoulder that fits through the assembly, and then the brake caliper, which is on the rear axle, pivots at the rear of the brake rod. This hole has severe wear and I need to deal with it. Likewise, on the brake caliper, the attachment point here also has severe wear. Two ways of dealing with this. One is that I could fill the affected area with weld and machine the hole back out again. The alternative is I could over enlarge the hole so it's round and make up a bush that goes through. I'm favouring the making of the bush, and there's a couple of reasons for this. I've welded alloy swing arms before. It's never a particularly satisfying process. This one's 40 years old, it's got ingrained dirt, all sorts of issues, and you can just keep bubbling away and preheating and bubbling away and preheating and bubbling away and eventually you get some clean welding done. The other issue is, it is only, if I get the focus right, get the right side, yeah, you can see that. It is only 2 bits of thin metal that make up the bracket. And because it's 2 bits of thin metal, it's going to wear again. Now admittedly this is 40 years worth of wear, so I might not be riding it in another 40 years time, but that doesn't mean that I don't want to do the right thing by it now. Now, a brake caliper, same sort of issue. It's also worn to one side. Again, I could weld that. It's still got the same issue. There's a lot of ingrained dirt, brake dust, etc. that has to be dealt with. But the other issue is also time, in that the whole thing, because there's rubber and plastic and whatnot in here, the whole thing will need to be stripped out. It's quite a thick piece, so there's a bit of preheating involved. None of that rubber and plastic and whatnot's going to survive that. So it's a pull it all the way apart and then rebuild the unit. And that's a time issue. Doesn't really need to be rebuilt at this point in time. It's been rebuilt a little while ago. So yeah, it's not where I want to go. So I'm going to do the same thing there. I'm going to oversize the hole so that it's concentric, and then I am going to machine a bush and fit that bush. So we've got it all set up in the mill now. We've got this section here parallel to the table. We will be machining a bigger hole that will take in the enlargement down here. We're machining a bush that will go in there. The original hole is 13 millimeters, and this top here is probably a remnant of the original hull, so we will set up the spindle to centre on that first and then go from there to machine out for the bush. For the brake caliper, using the same method as was used on the swing arm would have removed too much of the original lug. Here, the wear slot was simply machined out to be round, which meant that the mounting hole would end up being positioned off-centre in the bushing. Both bushes were turned out of brass, starting with the one for the swing arm. Both bushes were finished so as to have an interference fit in their respective holes. The centre of the swing arm bush was then drilled out to suit the shaft size. The brake caliper bush was then turned from the brass rod, but was left as a blank plug into which the shaft hole was drilled after fitting. The bushes have been fitted to the brake caliper and the swing arm. The brake caliper needs to have a hole drilled for the pin that goes through it. But before I get to the hole for the brake caliper, I'm going to fit both it and the swing arm bushes with what's known as Scotch keys. The way it's meant to work with a Scotch key is that you have a circular bush in a circular housing, and you put a screw in at the boundary between the bush and the housing. So I'm starting with the brake caliper. When I machined the hole for the bush for the brake caliper, it was off centre. And the reason I did that was that there just wasn't enough meat to accommodate having the bush in centre, which means the hole is off centre. It's not far off centre, but just a little bit. So what I'm doing now is I know where the real centre should be, and I'm going to find the edge of a machined section. The machined surface is 25 millimetres in diameter, and I will go in the 12.5 millimetres from each side, which will give me the centre that I need, and I'll go from there to drill the hole that I need for the pin that goes into or through the brake caliper. Hope you can see the edges there of the machined 25 millimetre section. Suzuki will have cast the caliper, and then they've just merely machined this area here and then pop the hole for the pin down through that. So there's nothing too sophisticated about this. I've got my centre in the drill chuck, and I'm going to come down to the edge of the machine circle, and knowing that, I'm going to go 12.5 millimetres in. I like to just check to make sure. That's pretty right. Now I'll go out to this edge here. Time to lock the table in place, spot drill it, and then drill it out. I'm ready now to thread my holes for the Scotch keys. The brake caliper I'm going to thread at metric 6 by 1 millimetre, M6 by 1. And the swing arm I'm going to thread at 5 millimetres, which is metric thread, a 5 millimetre diameter of the thread and 0.8 millimetre pitch for the screw. The reason I've gone for a smaller thread size in the swing arm is that the bracket itself is only about 3.5 millimetres thick. So if I go with 5 millimetre by 0.8, I've got 4 threads sitting in there holding it, and if I'd gone to M6 by 1, I'd only have 3 threads sitting in there holding it. Now let's talk about threads for a minute. As I said, for the brake caliper it's going to be M6 by 1, and the way that works is the 1 millimetre pitch, that's the distance between threads, and what that also means is that the thread depth is 0.5 millimetre. So it's 0.5 on each side, so the tapping drill becomes 5 millimetres. Very nice. Now the M5 one, the pitch is 0.8 of a millimetre. That means it's 0.4 of a millimetre deep on each thread, and it also means that the tapping drill is 4.2 millimetres. 0.8 from 5 is 4.2. Now the trick becomes drill size. This drill set is my metric set. Some of the drills are not original, some of them might be original. I've had this over 40 years. I've had it since time when Australia moved from imperial measurements to metric. Now, it's a very nice set of drills, but it goes in 0.5 mil increments from 1 through to 13, which means I've got 4 millimetres and 4.5 millimetre drills. I don't have 4.2. What that means is I'm a little stuck. So we could drill it out at 4 millimetres. You always run the risk when you go undersized with a tapping drill that you will jam the tap and end up breaking it. And I can tell you, having done this a number of times over my work life, there's nothing worse than breaking a tap in a hole. You can go to the next size, to the 4.5 millimetres. It just means your threads are all loose. Never quite sure that it's going to be tight enough. Now, what am I going to do? Well, what I did is more to the point. I have here an imperial set of drills. I didn't start with this set, I bought it later on because I think the boxes are a neat little trick. Anyhow, it just so happens that the 3/16 drill is, for all intensive purposes, 4.2 millimetres. So that's the drill I use to drill out the hole. So I've got the tapping drill size right for the M5. I'm doing the M6 first in the brake caliper. The cutting compound I'm using is called Trefilex. It just happens to be one that I like. These are hand taps, so every few turns you've got to reverse it to break the chip. I think the old formula was 2 complete rotations and back 1. I've just screwed in the screw that is going to form the Scotch key. You will have seen me use some thread locker. This is the red stuff. I'll call it the red stuff. It's a Permatex product. What the colour schemes usually is with thread locker is that blue is something you can undo with a little bit of physical force, and red is one that you will need to undo with a fair amount of heat. Now, the screw's gone in. It's not meant to come out. If you were to pull the screw out and push the bushing out, there's no guarantee you would ever get it correctly back in to align the thread to put the screw back in. So no point worrying about whether you're going to pull it out. I'll put thread locker on it, permanent thread locker, and it'll be locked in place. Shortly when everything is dry, I will cut the end of that screw off, dress it, and that will be the end of the job. If in the future the bush needs to be replaced, then it's a matter of drilling out the screw and pushing the bush out, more so than just undoing the screw. The screw's never meant to be undone. And again with the thread locker, now when that's dry I will just cut it off and maybe just touch it up with a file, and we'll be ready to reassemble. This is what the final assembly looks like when it goes back in the bike, and as you can see it's all nice and rigid, no untoward movement there. Hopefully good for another 40 years. This has all been part of a broader large service on the bike, and there will be videos on that in due course, but this one's more about machining, and that's why it'll be a standalone video on its own. I hope you've enjoyed the video, and if you did, I would welcome a thumbs up, and of course if you haven't already subscribed, well, I'd welcome your subscription. It's easy, just hit the subscribe bar down below. While you're there, ding the bell so that you get a notification from YouTube the next time a video airs on the White Dog Garage YouTube channel. Any comments, questions, queries, etc., put them in the comments down below. I'm pretty good at responding. Thank you all for watching, and I look forward to talking to you in the next episode. Thank you. Bye.